A very good day, madam. My name is Harishwa. My matric number is B0920103668. Today I'm going to do a presentation, short presentation about our subject, classification of air conditioning system. So first one is our introduction. So I'm doing my internship at Carrier, Malaysia, Sri Lanka. Most probably, you might know Carrier. It's more to about supplying their chillers, main units, chillers, issue, fan coil units, and some light commercial components and equipments. So for introduction, Carrier started providing HVAC and refrigeration solution from 1959 in Malaysia. Carrier experts in commercial, residential, and industrial applications as well as refrigeration solution in local. Carrier also well known in innovation of HVACR. The R is refrigeration industry and such as modern air conditioning invention by Wills, Haviland Carrier. So, what is refrigerant? Refrigerant is a mixture usually in fluid state. The purpose of a refrigerant is to absorb heat from an area and release to another. Refrigerant change to gaseous state when undergoes compression, condensation, expansion, and also evaporation to achieve the desired cooling point. Carrier mostly used for around four refrigerants, which is R134A, R1233ZDE, R410A, and R1234E or R515B as a backup. So the type of refrigerant refers to the specific chemical composition or substance in each refrigerant. Each refrigerant has varying properties such as boiling point, pressure temperature relationship, and also environmental impacts. For an example, R134A. The benefits of R134A is advantages of R134A is environmental friendliness. R134A does not contain chlorine, which make it ozone friendly. Next is global warming potential, GWP. While R134A is not without environmental impact, it has a lower global warming potential. Non-flammable is a non-flammable under most conditions, which enhance safety in the handling and use of the refrigeration system. Thermodynamic properties. It has thermodynamic properties that make it effective in wide range of temperatures. It is suitable for both low and medium temperature applications, making it versatile for various cooling needs. Next is our refrigerant R1233ZDE, low global warming potential. It has a very low global warming potential, which is GWP is 1. Ozone depletion, like many modern refrigerants, this refrigerant has zero ozone depletion potential. Thermodynamic properties. It has thermodynamic properties that make it suitable for use in both low temperature and medium temperature applications. Non-flammable, it's a non-flammable. Chemical stability, the refrigerant is chemically stable, reducing the likelihood of degradation and ensuring a longer lifespan. Next refrigerant is R410A, higher efficiency. R410A is known for its higher efficiency in heat transfer, zero ozone depletion potential, higher refrigeration capacity, and also longer term availability. Next is R1234ZE, zero ozone depletion. It has a zero ozone depletion potential, making it environmental friendly, low global warming potential, non-flammable. Then also thermodynamic properties. It has a suitable thermodynamic properties for certain applications, only for certain applications, providing efficient cooling. So the working principle for each refrigerant has got a specific working principle. Okay, so as a general one, These are the working principle for a refrigerant in a chiller or in any system, in any air conditioning system. First, evaporation, which is absorbing heat. Refrigerant cycle begins in the evaporator. The refrigerant enters the evaporator at a low temperature and pressure. When the air or other heat sources passes over the coil within the evaporator, the heat is transferred to the refrigerant. The refrigerant will be evaporated and turned into low pressure and low temperature vapor. Next one is compression, which is increasing temperature and also pressure. The low pressure vapor from evaporator drawn into the compressor. The compressor raises the pressure and temperature of the refrigerant vapor. After compressing the vapor, it will reduce the volume. Once after the compression, the pressure and temperature of the refrigerant vapor increases. It is now in a state that allows it to release the absorbed heat efficiently. Next is condensation, which is releasing heat. The compressed vapor then enters the condenser, which located outdoors and consists of coils and tubes. As the hot vapor passes through the condenser, it releases heat to the surrounding environment. The heat transfer causes refrigerant to condense, changing it from a vapor into a high pressure, high temperature liquid. The last one is expansion, lowering pressure. The high pressure liquid then enters into the expansion valve or expansion device. The expansion valve allows the refrigerant rapidly its pressure and temperature. The result is a low pressure, low temperature liquid vapor mixture ready to re-enter the evaporator and start the cycle back. Okay, so next is refrigerant used to achieve energy saving. In carrier, R1233ZDE is a most compatible refrigerant which is used by carrier, because carrier first option refrigerant is R1233ZDE, which is lesser energy consuming compared to other refrigerant. R1233ZDE is a hydrofluoroolefin HFO refrigerant that has gained attention as a more environmental friendly. The efficiency and performance of a refrigerant, including R1233ZDE, are influenced by its thermodynamic properties. First, the critical temperature and pressure. It has a critical temperature and pressure that determines its behavior during the refrigeration cycle. The maximum temperature and pressure at which the refrigerant can undergo phase changes from liquid vapor and also vice versa. Understanding the critical temperature is crucial for designing systems that operate efficiently across different temperature ranges. Specific heat capacity. The specific heat capacity of a refrigerant indicates how much heat it can absorb or release per unit mass for a given temperature change. This particular refrigerant exhibits specific heat properties that make it effective in transferring heat during the refrigeration process. Thermal conductivity. The thermal conductivity of a refrigerant influences its ability to transfer heat efficiently. Thermal conductivity for the refrigerant R1233ZDE can be measured in both state, which is liquid and vapor. The unit was Wm M-1, K-1. It has a thermal conductivity properties which contribute to effective heat transfer in heat exchangers, such as the evaporator and condenser coils. In a summary, the thermodynamic properties of this particular refrigerant R1233ZDE contribute to its efficiency performance in various ways, including its ability to absorb and release heat effectively, work well across different temperature ranges, and contribute to overall system energy efficiency. These properties make R1233ZDE a suitable choice for carrier Malaysia. That's all from me, madam. Thank you.